Example 3b, we're going to graph this one. I like to isolate y, so I prefer to move that 3 to this side so that the k value stands out with a positive 3, so that I can clearly see that this is up 3. I'm still going to have my reflection. This is going to reflect the x-axis, and I'm going to have a horizontal stretch as well. So I still start with that same table of values where I'm picking my perfect squares. Even if I don't plot each point, I might, because we're not sure what stretch is. And then I fill in, oh, I don't need 2, as I said that. I'm not gonna, I mean, that would have been the square root of 2, but we don't need to bother plotting that. Okay, now let's apply our mapping notation. We're gonna get 1/2 x, as it's a vertical stretch by a factor of 1/2. And we're gonna have negative y. So we're gonna cut all these points in half. 9/2 and 8. And then I'm gonna make all of the y values negative. Okay, and then I'm gonna have to go up 3 after that. All right, let's do this. Again, I'm gonna use pencil for this part. That's not my final answer. I know it's gonna be reflected. So I'm gonna have 0, 0, 1, -1, 2, -2, 4.5 and -3, 8 and -4. So this is what the shape's going to look like. And again, oops, it kind of went off there a little bit. Good thing I had pencil. Okay. So that's what y equals -√2x would look like. And now let's shift this up 3. So I'm going to take each point and move it up 3. And we have that there. Okay, and so this would be my final answer right here. Okay, let's look at the domain and range. It asks for domain and range in each of these. So the domain would be x is greater than or equal to 0, which, if you look at the equation, is also the restriction, right? You can see it in the equation, or you can look up here. And then the range, y is now less than 3. So the fact that it's less than is because you had a reflection. So y is less than or equal to 3, where y is the element of real numbers.